Hi guys, Mr. Bowman here, and today's learning objective is in blue, and we are learning to solve quadratic inequations. The best way to get into this type of question is to go through an example. So let's have a quick look. Question 1, x squared plus 5x greater than -6. So quadratic inequations are like quadratic equations, except we're dealing with greater than or less than and equal to signs. We can use similar procedures to solve our equation, except unlike linear equations, there is a limitation to what we can do with our equation, and we do need to visually inspect what this graph might look like to help us come up with our final answer or range of answers. So let's get into it. First step, like quadratic equations, we need to make sure our inequation is relative to 0. So what that means is we need to get rid of this plus 6 or that minus 6 by adding 6, and that means we've got to add 6 to the other side as well. And that would come to x squared plus 5x plus 6. That would be greater than 0. Like we would for quadratic equations, we're going to factorize. And it is at this point here we can't really develop our quadratic inequation anymore, and we need to switch back to an equation to find out the two x-intercepts or the two roots of the parabola. So we need to solve x squared plus 2 and then x plus 3. Our first value of x would be -2, and our second value of x would be -3. And what that tells us is the two x-intercepts of our quadratic inequation. So let's draw some axes. So that's our y-axis, that's our x-axis. What we're going to do is we're going to draw -2 and we're going to draw -3. And those points we can use to construct what our parabola looks like. So based on the x squared, it's positive. We know it's going to look like a positive parabola. We're just going to draw a very rough parabola to identify which values are greater than 0. So I'm just going to change pen colors. I'm on to green. So if you have a look at our parabola, any values above 3 in this range, they are all above 0. And any values above that number, they are also above 0. So that means anything more than -2, that's going to have a positive y value, and anything below -3, that is also going to have a positive y value. And what that means in the middle, any number between -3 and between -2, that is either going to be 0 or negative. And they don't meet the inequation that we are currently looking at. So when we look back at our equation, what values of x are positive? We know that anything above -2, that's going to be positive. And anything below -3, that's also going to be positive. And that would be our solution to our quadratic inequation. So that was our first example. Let's have a look at another one. So we've got x, and then in brackets, x minus 7. When is that less than negative 12? So like we did with the first example, we need to rearrange and make one side of our inequation 0, so we can then use our solving quadratics approach to answering this question. So we're going to go x times x is x squared minus 7x. When is that less than 12? We're then going to get that 12 and eliminate it to make sure that side is equal to 0. Because we added 12 on that side, we're going to have to add 12 to the left-hand side as well. And that means x squared plus 7x. Oh, apologies, I'm just going to delete that. Minus 7x plus 12. That is going to be less than 0. Like a quadratic equation, we're then going to factorize, which becomes x minus 3, x minus 4. And that is as far as we can go with our inequation. We then need to revert back to equations to calculate the roots or the values which that inequation will be equal to 0. So our first value would be 3, and our second value based on the second bracket would be 4. So we know that parabola has x-intercepts of 3 and 4. From that, we can draw a rough parabola. So our graph or our inequation would look a little bit like this. And we need to go back to our final steps of the inequation. We need to find out for which values of x will the graph be below 0 or less than 0. So let's change pen colors. We're in green again. So another way to think of that, because we're looking for less than 0, for which values of the graph are below the x-axis that I've bolded in green. And in our case, the numbers that fall between 3 and 4, they will have negative values or values less than 0. So we'll just highlight that, all those ones there. So that means if we think of our inequation, values that are below 4, they are going to be positive. Sorry, they're going to be a negative value. And values above 3 are also going to be. And we're going to put that into one equation. So x must be between 3 and 4 for there to be a 0 or negative value. And I'll just square, that's our final answer there. Right. So hopefully that makes sense. This skill is a big step up from what we're doing. This is an extension skill. And I do want us to give us this our best crack, but it is not the most crucial skill in terms of our development, because we will look at this again later on in our schooling career. All right. Thanks and have a great day.